see, page 3 of solids. Copy the cuboid shown and mark the angles described. Use a different diagram for each angle. Okay, the angle that the face ADHE makes with the line EG. So we'll mark the line EG. It's right there. And then it says the angle that the face ADHE makes. So let's try to mark the ADHE. That's the bottom one here. So that angle would be this angle here. Okay. B. The angle that the face ADHE makes, same face, with the line EC. EC. So that would just be like that angle right there. C. That was B. The angle that the face EFGH makes, let's see, EFGH would be that face, makes with the line CE. CE. Okay, so this one would be, this is kind of hard to imagine. So it would be that angle right there, right? D. The angle between the lines CE and CF. CE and CF. That was easy. It's easier to draw the ones between two lines than between a line and a plane. The angle between the lines CE and EA. CE and EA. Okay, it's kind of slanted, right? Okay. You can draw like the third side if that helps. 3. Copy the diagram of a square-based right pyramid. Mark the angles described. Use a different diagram for each angle. The angle between the base of the pyramid and the edge, EC. EC. So EC is that. And then it says between the base of the pyramid. So basically, it's that angle there. B. The angle between the edges EC and AE. EC and AE. Wow, okay. It's kind of like that. Okay? And the angle between the line ME and the base, where M is the midpoint of CD. So there's M. ME would be that line there. And it's with the base, so it would look kind of like that. Okay? Alright, moving on. In the cuboid ABCDEFGH, AD is 10, CD is 4, and AE is 3. They're all marked here. Calculate the length of AC. AC. So let's draw AC out. And we can see that AC forms a triangle with two of the other sides, and we'll just label the length of each side, and then we'll be able to figure out, like the bottom of the triangle here is 10, the side is 4, and then we're just trying to figure out what the hypotenuse is here. So we could just use Pythagorean's theorem, right? X is equal to the square root of 16 plus 100, which is equal to the square root of 116. Okay, so that is the length of AC. Find the angle that AG makes with the face ABCDE, or ABCD. AG makes with the plane ABCD, I'm sorry. So actually it's this angle right there. So again, we can use the triangle that forms. See if we can label the sides and everything. So one of the sides is square root of 116, which we just found. The bottom part of it, right? This part of it. And then the height is 3. And we're trying to figure out the angle here. So we can figure out the tangent because we have opposite over adjacent. So how about if we do that? We do tangent of theta is equal to 3 divided by square root of 116. And then we can just put that in the calculator. 3 divided by square root of 116 And then we'll just take the inverse tangent of that. And that gives us, ooh, and I think it's in radians, so let me change the degrees. Mode degrees, and then we'll go back out, and then I'm going to try that again. Now it's going to give me the answer in degrees. So it's 15.6 degrees. So theta is 15.6 degrees. Then it asks to calculate the length of AF, which is that length right there. So let's see, we draw another triangle. And this time, the height, again, is 3. And this part AB here is 4. So now we can already know that the hypotenuse is 5 because the square root of 9 plus 16 is the square root of 25. Okay, so the answer to that is 5. Now it says find the angle that AAFB makes with the line AG. So where's the line AG? The line AG is that line, and it says the plane or face AEFB, which is AEFB. Okay, so now we're going to find that angle right there. And so if we're going to draw that triangle, let's see. So this part here is 10. This part here we just found it's 5. And then we're finding this now. Okay, so now we're finding this angle. So this angle we can find with the tangent. The tangent of theta is equal to the opposite, which is 10, divided by the adjacent, which is 5. So tangent of theta equals 2. And so if we take the inverse tangent of 2, it'll give us the angle size, which is 63.4 degrees. 63.4 degrees. Okay, and that's the answer to that one right there. All right, last one on this page. The diagram shows the cuboid ABCDEFGH, where AD is 4, CD is 6, and CG is 9, and they've already drawn the picture out for us. Calculate the length of BD. Let's see, BD. BD is that one right there. So if we drew this out, BD has one side which is 4 and the other side which is 6. And so BD would be the square root of 36 plus 16, which is the square root of 52. Okay, so that's BD. And then it says find the angle that AE makes with the face BFGC. So BFGC is that one there. And then it says find the angle that AF makes with that face. AF is that line there. So they actually want that angle. Okay, so let's try to draw that triangle. That triangle would be, let's see, the bottom, this part would be 9, and then this would be 6. So this, you could do this with tangent. So the tangent of theta is equal to the opposite, which is 6, divided by the adjacent, which is 9. That's equal to 2/3. Right? So let's see. Inverse tangent of 2/3 is equal to 33.7 degrees. Okay? All right. B. Find the angle that AF makes with the face ABCD. So that would be AF makes with the plane ABCD. Okay, so that's this angle right there. So let's draw that angle. So that would be height of 9, and this length here would be 6. And we're looking for that angle. So this time it would be tangent of theta equals 9 over 6, which is 3 over 2, 1.5. So now we just find the inverse tangent of 1.5. And it tells us it's 56.3 degrees. Okay? And that's the answer to B. C. Calculate the length of AC. AC. So AC is across the bottom there. And what do you know? AC, that should be the exact same length as BD. We already calculated BC, which is square root of 52. Because they're diagonals on the same rectangle. Now calculate the length of FC. FC. So FC would be this diagonal right there. So let's see. The bottom would be 4. That's 4. And the length would be 9. And so we're trying to figure that out. We're going to figure it out with Pythagorean's theorem. So it would be the square root of 16 plus 81, which is equal to square root of 97. Okay? And then find the angle between the lines AF and FC. AF and FC. So that would be between those two lines. Wow. So that's kind of a challenge here. This is the hardest thing we've done so far. So what about this line? This line, FC, we already found out is square root of 97. And what else do we know? This bottom part, which is AC, we know is square root of 52. And now we can find the length of AF pretty easy, because AF, we know the height of this triangle is 9, and we know that the base is 6. So to figure out this length, we can use Pythagorean's theorem. It would be 36 plus 81 square root, which is square root of 117. Okay, so now that we know all three sides, we can figure out this angle pretty easy because we can use the law of cosines. For example, we could say, oh, c squared equals a squared plus b squared minus 2ab cosine of capital C. So if cosine, if this is a, if that's a, then the small a would be small, or the small c would be a. And the other ones are called f and c, right? So f squared plus c squared minus 2fc cosine of a. Okay? So f squared is square root of 52. C squared is 117. Minus 2 times f times c is 107, square root of 117 times square root of 52. And then the cosine of a we don't know yet. And that's equal to a squared, which is 97. Okay? And so we could just solve that for cosine of a. Well, so we'll start out with 97 minus 52 minus 117. That gives us negative 72. Then we're going to divide that by 2 and square root of 117 and square root of 52. And then that would give us a negative number, and then we're going to take the negative of that because we have this negative here, and I'm sorry I'm skipping so many steps. So we're going to take the negative of that, and then we're going to take the inverse cosine. Inverse cosine of this. So the angle is 74.3 degrees. So this angle here is 74.3 degrees. Okay, and that is page 3.